All right, writing equations from a graph. So today we're going to be given a graph, and from the graph we're going to write the equation. These will be quadratics. We're going to wrap up quadratics this week, hopefully, and then next week we'll look at exponentials going into our test. But as far as writing equations from a graph, we're going to start with vertex form, which is what I have up here at the front. You're going to be given a vertex, and you're actually going to be given an entire graph. All right, so if you have a parabola that looks like this, right? The only piece of information that you must have is this vertex. So for number one, if this is number one, we're going to write the equation from the graph. So it's kind of working backwards from, being given the equation, find the vertex, and then graphing it. We're going in rewind here. So this time, if the vertex is at the point 3, 5, we're going to write it in vertex form. We're just going to write this, okay? So what you have to be careful on though is the signs right here. So y equals, now the a value is what tells us does it open up or does it open down. So if it opens up, this is going to be positive. Now for what we're doing right now, normally we maybe do a little bit more with this, but we're just going to look at the two symmetric points are up 1 and over 1, so it's going to be a positive 1. If this opened down, you would put a negative 1 right there. And this is actually a spot you could get away with not even writing anything there, because in front of the parentheses we can always assume there is a 1. Okay? All right, so then from there we're going to go x minus the x value, which is the h, which will go, in this case it's a positive 3, so it's going to turn into x minus 3. Okay, don't forget the squared up here, which, excuse me, on what we're doing, maybe fill in the blanks. So you may just have to fill in these spots. And then our last spot to fill in is the vertex. Now, what's tricky about this is that this one, we had to change the sign. It was positive 3 here, we plugged it in, it became negative 3. This sign is going to stay the same. So that is plus 5, and there we go. We're done with that one. Now, we could write this, I'm just going to go ahead and say that this when it's positive 1, you could get away with the same thing, x minus 3 squared plus 5. Let's just assumed there's a 1 there, but you don't have to write it. So both of these are correct, they're equivalent, they mean the same thing. So there you go. Number one, you can pause it if you want to go back at any spot, or just start from the graph and try that on your own. Okay, for number 2, another one in vertex form, we're at the point -8, -4. Okay, let me make sure you can see that. And then this one is going to open this way. Okay, so -8, -4. So I would write that out. So if you're given this, I would count out the spaces, -8, -4 right there. Because really, we don't even have to have the graph to try to, as long as we know what the vertex is and we know if it opens up or down, that's what we need to know. So this one opens down, so it's going to be a negative a value right here. So here we go. For number 2, we're going to go y equals the a value times x minus that squared, fill in the blank here, and fill in the blank there. All right, so it opens down, so this is a -1. The x value matches up with h. I'm not sure why they decided that a long time ago, but they did. X and h kind of represent the same spot in this case, but -8. So x minus a -8. So that is the reason we have to change the sign, because the formula doesn't change, but when this is negative, minus a negative turns to plus a positive. So if you just want to write x plus 8, that is fine. And then the last one, it does not change. So it actually stays the same. So you could leave it like this, but if it's fill in the blank like our homework, we can have negative. You can put the -1 if you want, but you don't have to. X plus 8 squared minus 4. Right? And there we go. That would be our solution, or not our solution, that would be our equation for the graph. Okay? So there's 2 of them in vertex form. What we're going to do now is I'm going to show you 2 more where we actually start out going in vertex form, and then we move it and go ahead and finish it up to put it into standard form. So let's go ahead and do that now. All right, so for number 3, again, the question is you're going to be given the graph or the vertex, and then you have to write the equation from there. So in this one, we got standard form from 2, -6. So that's down here, and this one is going to open up. So here's our graph. All right, so you're given this. So we've got the point 2, -6. So the first thing I would write down, vertex is 2, -6. So do that first. Okay, you can write it, same thing. You put 2, -6 if you have it on paper. I know right now we don't have paper, but this is what I would do. Okay, you can write it off to the side. So if we're going to go to standard form, we're going to go from here and then into y equals ax squared plus bx plus c. So if we want to get to standard, we're actually going to do this first, and then we're going to multiply it all out and get y equals, we're going to solve for y with everything multiplied out. So this one would be y, it opens up, so it would be a +1 times x minus the x value, so it changes to a -2 minus 6. So far we've been able to stop there. But what I want to show you is we can go from this into standard form because this is squared, right? We have a +1 out here. So we would just split the x minus 2 times x minus 2 minus 6. Now it's been a while since we did this, but this is really good for review for you guys because as we get to the end here, I'm not sure, hopefully you've already heard this, but we're not having finals, so we're not going to have this on the final, but this is a good review just to go over this again, to have seen it. This goes back to polynomials, so we actually have to double distribute this, and we get x squared minus 2x. Then we distribute this one minus another 2x. Negative is a +4, and then don't forget about this minus 6. So I've got like terms here and here. So then my final answer on this is going to end up x squared minus 4x, and that's going to be minus 2. So that would be the standard form for this graph. Okay, so we still use vertex form to get started, then we solve it, we multiply it out with polynomials. Okay? All right, so there is number 3. Like I said, pause at any spot if you need to pause it now to catch up, or shoot me a Canvas message. I would love to help you out. So, all right, last one here for the notes today. Keep the same formulas over there. This one we've got a point at -4, +2, -4, +2. This one's going to open up again. Okay, so this one's going to be positive. So you're only going to be given this theoretically. Okay, or on the paper they might write the vertex, or because it's on the computer, if I run out of pictures, I might give you one with just a vertex to do. But all you really need to know is the vertex, and does it open up or open down? So this one definitely opens up, so that's going to be y equals 1. Okay, and then from there we've got -4, +2. So -4, +2. So that information, does it open up or down, and the vertex are all you need really to set this up and solve it. Okay, so we get x minus a -4 turns to +4, and this is a +2, so we just put +2. So the tricky part of that, the x value changes signs, the y value does not on this part. Okay, now we have to multiply this out, so here we would be done with vertex form, but to get to standard form we have to multiply this out. So we're going to do x plus 4 times x plus 4, and we still have the +2 out there. This 1 we don't have to write, and we're going to double distribute. So we get y equals x squared. The x squared is here. X times the 4, we get plus 4x. Now we're going to do the second distributive property here. 4 times another x. And last 4 times 4, we get 16. Now don't forget about the +2. This time I have 2 different like terms. And so my final answer here, I get x squared plus 8x when I combine those like terms, and plus 18. Okay? And there you go. That would be what we're going to do today here with writing equations from a graph. You'll be given the graph, you got to get to here. So make sure you pay attention which one it asks for. So if it asks for vertex form, that's a lot faster. You just get a stop there. If it asks for standard form, you got to multiply all this out. Okay? A little bit of review of polynomials. Hope everyone is doing all right out there. Please let me know. I'm trying to work on contacting some of you about just different things I can help you out with. If for whatever reason I don't contact you and you feel like you have a lot of questions, please send me a Canvas message. I'm probably going to see here in the next, we got 4 weeks left, at least as of right now. For some of you, if I use this video again, it might be at a different point in May. But anyhow, please reach out. Let me know if you have questions. I want to help you out, and I hope you guys are doing well out there. Okay? So thanks today.